Well, greetings, everyone. This afternoon, I'm really pleased to introduce Dr. Justin Magruder. Dr. Magruder is a graduate of our information quality doctoral program, and he has had a number of very interesting experiences. First of all, for the last almost 4 years, he's been the Chief Data Officer for SAIC. And I'll let Dr. Magruder talk a little bit about who SAIC is. It's one of these companies that here in Arkansas, we don't hear too much about SAIC, but they're actually a huge company, and they are in a number of different industries and providing a number of different types of services to their clients. But he's been an advisory board member for the NSF Arkansas established program to stimulate competitive research. He's a working group expert member of the Technical Committee 184, Automation Systems and Integration. And he has been a founder and a chairman of Noetic Partners. And he has also been director, chairman of the Finance, Banking, and Insurance Committee for the Electronic Commerce Code Management Association. And again, if you go out to his LinkedIn profile, he has a number of additional experiences, but I'd like to turn it over today to Dr. Magruder to definitely continue your introduction and share with our students about some of the topics related to data governance, data quality that you would like to share with them today.
Sure. Thank you, Dr. Pierce, for the introduction. Hi, everybody. It's nice to see you. My name is Justin Magruder. I'm currently the Chief Data Officer for Science Applications International Corp., or better known as SAIC. SAIC is the United States government's and really the Department of Defense's biggest system integrator. So we have 25 or 30,000 software engineers and data architects and other staff who help the U.S. government build many of its most complex systems. And I'll give you an example. Last fall, about a year ago, some of you may have seen the Artemis space launch system shoot the Artemis rocket, the biggest rocket ever built, up around the moon and then back safely to Earth as an unmanned spaceship. Next time it'll go with people on it. We wrote all of the guidance systems and the monitoring systems for the Artemis space launch system, which is very complicated. That's just one thing we've done. We've also worked with our biggest customer is the United States Navy, and the United States Army is number 2, Air Force is number 3, Treasury is our newest big customer, and they hire us when the usual suspects aren't able to handle some of the more complicated activities. So we've got a great group. My team employs, I've got 4 UALR grads working for me and with me, and one student is currently in the program. So just so you know, we are prolific UALR students and alumni. So I put up on the screen the presentation I gave to my dissertation defense a few years ago, and I put it up because yesterday SAIC submitted a version of my paper as a white paper to a group called the Data Foundation, which is organizing the procurement by the U.S. Treasury, the Securities and Exchange Commission, the Internal Revenue Service, the Federal Deposit Insurance Corporation, and about 9 other federal agencies in the financial sector, as well as the Department of Defense, to be the solution for the Financial Data Transparency Act of 2022, and several other supply chain issues. And I wanted to mention that because you're in the program I was in 2 or 3 years ago, and it can take you this far where it's now being considered what we did in my program with help from Dr. Pierce and Dr. Talbert and all sorts of people, and a number of other students and graduates. It is now, we've patented it. It's got a US patent. It is being discussed at some very high levels in the US government as a solution to a problem no one's been able to solve. And someday, if you want, I'll get into it with you of what exactly we came up with. It was a design science research proposal, and it came up with an interesting solution. So I'm going to switch pages and go to
and Dr. Maybe you could just tell the students what was the problem here, and you can just pick an example of an organization, and why is it so hard to come up with a unique identifier?
Absolutely. Well, first of all, the problem is, and I can show you a little bit of my document, but there are thousands of organizations over the past, I'll say 100 years, who've begun to develop and are now operating legacy systems that are embedded in business processes around the world to identify things in general. What I realized after 25 years in financial services is that there needed to be a solution that crossed all the boundaries. And we couldn't figure out, for years, we trusted the authoritative sources that we needed to use. I was at JP Morgan, I was at Deutsche Bank, I was at UBS Investment Bank, and some other very big global firms. And what we wound up doing internally, I ran data programs in those banks. We took in hundreds and even thousands of different data sets and had to design our own integration solution so that I could connect the issuer of a stock in the United States with the issuer of a stock in Switzerland. In the US, we have a CUSIP. In Switzerland, they have a Valorum. In London, they have a CEDAW. ISO has an ISIN. All those things describe the same security or different versions of the security issued by the same, the key thing is issued by the same juridical party or organization. So if it's Facebook Meta or Amazon, or if it's General Electric or even UALR could issue securities to raise money to build buildings and improve the campus. So we needed a way to identify uniquely all of those issuers and all of those issues. And it's a problem I worked on for 25 years until I got to UALR. And I worked with some of the smartest people around, I think, including at UALR. And that's where we finally solved it. What we did is we created, this is what design science is. This is the methodology we used. So in the world of fast-moving, complex financial markets, a lot happens. At any moment, right now, the markets in New York and the United States just closed 15 minutes ago. There are probably 10 to 25 million, and I'm not sure what it would be on a day like today because it's midweek, but 10 to 25 million records per second running through the consolidated tape, which is a collection of all the security messages being sent around the world by markets. So London closed 6 hours ago, but they're still sending messages, and they'll send messages all night. The volume goes down. Frankfurt closed, London closed 5 hours ago, Frankfurt closed 6 hours ago. They're still sending messages, trying to reconcile trades, trying to make sure they got the right price, the right information. So at any time during the week, and now with crypto volumes, and especially Ethereum 2, volumes are skyrocketing. On top of that, currency transactions happen 24/7. Cryptocurrency transactions happen 24/7. So lots of people want to keep track of that. I'm going to jump to the end. What we came up with was a composite identifier based upon 4 ISO standards that replaces all of these and about 100 others, or helps us organize them and connect the dots between all the different ways of identifying issuers and instruments. It also turns out to help us solve a few other problems. I'm going to show you a use case that we came up with the U.S. Department of Defense, if I can get it. Let's see, where is it? Bear with me. It's a pretty cool use case. Yes, here it is. So at SAIC, we do a lot of work with the U.S. Navy. That's a picture of, I think that's the 7th Fleet. And here's the use case. On January 19th of this year, the Navy's 7th Fleet participated in an exercise with the Sri Lankan Navy, just outside of Colombo, Sri Lanka. At the same time, the 10 or 12 ships in the fleet resupplied in Colombo, and they got fuel and food and medicine and all sorts of supplies. The question the DoD needs to know, which they can't get electronically today, is where did the eggs come from? Where did the milk come from? Where did the penicillin come from? Where did the meat come from? And using the technique that we developed at UALR, we proved to the Defense Department and to a few other agencies that needed to know that we could trace the origin of these eggs all the way up its supply chain at the very beginning, to the farms around the country of Sri Lanka that produce eggs. We also learned that there was some good academic research, and we could overlay the view of these egg producers and distributors with quality scores, because there's been quite a bit of academic research about egg quality in Sri Lanka. And then we also realized we might need to understand the political or social connections between some of these agencies. This is important because in this world today, there's a lot going on. And as you mentioned, Dr. Pierce, there are a lot of people who are quite politically active throughout Europe, with Ukraine, in the Middle East with Israel and Hamas in Gaza, and in Taiwan and around the world. Without taking any sides, we just want to be able to look at all the supply chains and understand where we're getting our foodstuffs from. So that's one example. Another example is back to the financial use case. We looked at Stephens Inc., which is a investment bank located in Little Rock, Arkansas. And we realized there were, I've got on the page here, 12 ways to identify them just off the top of our heads. It turns out there are a few hundred other ways of identifying Stephens Inc., which is a bank that makes investments and issues securities. So it's an issuer of securities. We have to be able to track those securities all day long as they trade in New York or London or Tokyo or Mumbai or anywhere around the world. So we do it using these identifiers, but they're a patchwork. They don't connect to each other. So we realized we could get some information about Stephens Inc. and model it. And what we realized is this information is really like a birth certificate. So just like each of us has a birth certificate that is recorded by the state or country that you live in when you're born, they make a note of it in the registry, and they forever know that you were born on the day you were born in the place you were born. And that's how you become a citizen of a country. We can do the same thing with a company. So we looked at the proxies. All these numbers on the right are numbers that describe Stephens Inc. And you can tell they don't match up very well. It's hard to connect the dots between them. So we needed a technique to do that. So we took ISO 8000 part 116, also ISO 8000 part 115, ISO 3166 Part 1 and ISO 3166 Part 2. And then Dr. Talbert and Daniel Pullen, another UALR grad, and Diane Schmidt, another UALR grad, developed a method for improving on the ISO specifications. So you see that BER in the middle? That doesn't tell you what that stands for, and I'll describe the composite ID to you in a second, but that doesn't help you resolve it. You don't know where to go to find out if this ID is true. The first part is ISO 3166 Part 1, country codes, the US. There's a dash. The second part is the ISO 3166 Part 2 subdivision code for Arkansas, where Stevens Inc. was registered when it was first formed. But the BER doesn't tell us where to go check this. It turns out there are three more, maybe four, but three pieces of information we can add to the to this sub prefix that will help us go directly to that registrar electronically over the internet and check this data to make sure it's correct. So we called it the Noetic Party Identifier. Noetic is the name of my company. It's also an adjective that speaks about of the mind, of logical, thoughtful, and that's how we think in Noetic. So we took this idea. I'm going to jump ahead because this wasn't the presentation I meant to go through completely, but I did want to show it to you. We take this second idea, the subdomain, number 2, and we decided we could expand upon it because the ISO standard isn't a rule or a law, it's a standard, and it allows for this. So we added 3 features. First, what kind of company is it? What kind of person is it? Is it a natural person? Is it a company? Is it government? We've since gotten a little more granular. Who's the registration authority? So in Arkansas, the registration authority is the Secretary of State. And they have within that Secretary of State another department that does the registration, and you'll see that in a second. And then the third part is the date. We need to know which date it was registered on, because it turns out that some places reuse the registration identifier, which is a critical piece. So they would reuse them on an annual basis in most cases, like New York does. New York City and New York State both reuse numbers. So you have to know the date, because there's not going to be more than one ID number in a year. They go their sequential integers, and then they start over again on January 1st. So what we got is this identifier. And it turns out this identifier can be used, and within SAIC we've done this now, to identify almost 300 million companies around the world. And to put that into context, if you go to the Global Legal Entity Identifier Foundation, you'll find a number of people who've gone for 15 years now around the world, spent lots of money from government to register all the legal entities that are involved in supply chains and banking system. They have 1.5 million active IDs. And they have another million inactive IDs. So 2.5 million companies total. But I can tell you a lot of their data is wrong, because as a test 10 years ago, I went out and registered my company, Noetic. And then I changed my company's legal form from an LLC to a C Corp. They still think I'm a C Corp, an LLC registered in Virginia, but I'm not. My company's now a C Corp registered in Delaware. So their information is wrong. And they maintain it in their database, and you can search for it today and find it. Other organizations like Bloomberg, Thomson Reuters, or what's now called Refinitiv, Standard & Poor's, and a number of others also have IDs. And the most of them, Dun & Bradstreet's probably the most generous database with about 10 million. So we still have 3 orders of magnitude more registrations that we can prove are accurate the day you check it. And Dunn's doesn't do any validation. I have several Dunn's numbers for my company because they keep getting confused about me. So they only update my records when a customer asks them about me because they're going to hire my company. And that's when they call me to make sure I'm validating my various factors. And they ask for information that I don't think I want to give them anymore. This method that we described here on the page is an open method. It took a lot of work to get it to the place where it is now, which is ready for prime time. And it's really industrial strength. So I'm going to break it down for you. In the domain, we have the country code and the subdivision code. That's ISO 31661 1 and 2. The subdomain is the stuff we invented as part of the design science project. The entity type is the type of company. The SOS is the registration authority for that particular domain. And the date is the ISO formatted date string. I should have mentioned that ISO standard also. And you see there's lots of punctuation. The punctuation is important because it helps you delineate each of the pieces of the ID so you can read it and understand it. And the last piece is the identifier itself that is issued by the registrar. Now, you may say you don't think you don't think meaningful IDs are a good idea. We've been saying that for decades, and I disagree. It turns out this is an important feature of an open data standard so that anyone in the world can read it and understand it. Now, if you want to make your machines go faster, you can hash it into a GUID or something else, but this really are into some sort of different kind of ID. This is an identifier that anyone in the world can read and understand as long as they read English, or they can use ChatGPT to translate it into about 100 other languages, from Mandarin to Swahili. So that was my research project. It went over well enough that I graduated, and it's now become the centerpiece of my new company's SAIC's data strategy. Now I'm going to walk you through that data strategy. I'm not going to show you the newest one because it's got a lot of stuff in it that I'd love to go through another time. I want to show you the original formative data strategy that I wrote in the first 3 months when I arrived at SAIC in 2020 during the COVID pandemic. So let me toggle over to that.
Right, and I'll just interject for the class. And the reason why this is so impactful is this is an example. You think, oh, we would like a unique universal identifier. I mean, that seems so straightforward, and yet as Dr. Magruder says, this is incredibly difficult. We've been working on this for like hundreds of years, but it's incredibly useful because there are use cases. You saw the supply chain, but just to give you an example, when there is a food recall, like there's a salmonella outbreak and it's associated with lettuce, what happens is stores like Walmart and Kroger, they have to throw out all their lettuce, even though that they may not even be impacted. And it may be that only one box of their 20 boxes of lettuce actually comes from that farm that had the salmonella. But because they don't have a unique identifier, all they know is we have 20 boxes of lettuce. And so this ability to be able to trace something to its source has huge implications. So anyway, thank you so much for sharing that, because many of these students are thinking about a PhD or doing a master's project. And it's an example of, be on the alert for, where there are problems and how you might come up with an innovative solution to address that problem.
Exactly. This problem is prolific. There are so many social and political boundaries to sharing information like this. And that's why the ISO standards are so important, because that's how we agree to share. And working on ISO for the last decade or so, that was the committee that Dr. Pierce mentioned when she introduced me earlier, has been fascinating because it turns out that things that seem very clear to me and might seem very clear to you are not clear to our colleagues in France or Korea or India or Russia. And so we get around the table once a month, usually on Zoom, and we share a lot of data, and we work through the problems. And it turns out it's hard to get to an agreement with 50 people on an ISO technical committee, because we all have different experiences, different use cases in our businesses, whether it's eggs or lettuce, or whether it's fuel or lithium to build batteries for electric cars. Lithium comes from China, Bolivia. There's a new big discovery in northwestern Nevada and eastern California that looks to be one of the biggest in the world. That we need to know where it comes from. Who are the miners who dig it out? We have to make sure they're not using child labor. Who are the truckers who ship it from the mine to the processing facility, or from the farm to the table? All of these things make up the global supply chain, which is more than 300 million companies, which is why we needed a technique like the one we developed here at ULR. So let me step into SAIC's enterprise data strategy. Now, I wrote this, as you can see, about 3 years ago. I'd been with the company for 3 months. I knew very little about the company because I came out of banking technology for 28 years. And I knew a lot about banks and trading and investing and all the technology used to do it. And I worked around the world with banks. I worked in New York and Boston and Chicago and Dallas and the big hubs in the United States. But I also worked in Mexico City for about 5 years. I worked in London for several years. I worked in the Middle East, in Abu Dhabi and Dubai for a bit. I worked in East Asia for a little bit, and have spent some time in Japan and China and Australia and Taiwan. So I got a taste of a lot of things. And so I learned a language. And I think that's how I like to think about this. When I came to SAIC, I found out that the language had changed, but not everything. All the nouns were different. Instead of stocks and bonds and derivatives and hedges and things like that, we were talking about warfighters and soldiers and theaters and strategies and different concepts. But it turns out all the verbs, all the things we do with data are the same. And it took me about a week to figure that out. Because everything I heard, I thought back to something, every problem I heard about when I arrived, and I got an earful. I hearkened back to things that we'd had to fix at JP Morgan or Deutsche Bank 10, 20, 30 years ago when I was brand new in the business. And so I learned that government moves slowly and deliberately. And as a result, they're behind industry. They've got some stuff that's really cool. And they invest heavily in certain things that are pretty interesting. And some of the groups that I work with now did things like inventing the internet. I'm working with DARPA, the Defense Advanced Research Projects Authority. And they are known for inventing the internet in the late 60s. And they're doing a lot of other cool stuff like that, one of which is connected to my PhD dissertation. So let me step through this deck. This deck was developed and presented to the executive leadership team at SAIC and also to the board of directors. And it was the first of 3 strategies. I've just published my 3rd one about a month and a half ago, but it's got some sensitive information in it, so I'll show that to you next year. The one that's about 18 months ago I can show also. I don't think we'll have time tonight, but if anyone has questions after the session, please reach out to me and I'll see if I can talk you through some of these things. This really shaped what has now been SAIC's decision to transition to the cloud. Until this time, there had been a sense in the US defense community that cloud computing was not secure and that we should put everything on premise in a data center so we can put guards around it and protect it, and we'll keep people out that way. What we've learned is there's no difference. In many cases, cloud services may be more secure if you follow the right protocols, and we're very good at that. We run a lot of cyber ops for the US government and have developed a lot of those techniques. But let me tell you what our strategy is. And this strategy is still good today, by the way. We build on top of it. The second strategy and the third were additive. They didn't replace this or change the direction. So the point of this review with management was to describe what the strategy is and establish consensus. We needed them to understand that there were building blocks, that we couldn't just build a big data warehouse and fix everything. Data quality was much more complicated than that. So we needed building blocks to help them get information out of their data so they could get knowledge out of their information. We needed to demonstrate the value, like why does each building block need to be built? We needed to tell them how much it was going to cost. Was it worth it? And then we needed to sort of outline the roadmap to get to the launch. So these are quotes. When I first arrived in June and July of 2020, wearing a mask, I walked around and talked to the senior leadership team. And there are about 10 people on the executive leadership team. My boss is the head, basically the chief business officer, otherwise known as the chief operating officer. He kind of runs everything. And then we have financial people and sales people and marketing people. But he got me access to everybody, and I walked around, and everybody said, and these are quotes that you see. And I got these same quotes from when I consulted London Stock Exchange Group for 5 years and did the same thing with their executive team. When I was hired by Freddie Mac, which is the U.S. mortgage, one of the two U.S. mortgage secondary market managers for the government. It's a big quasi-public company that processes about half of the U.S. mortgage market transactions every day. Same quotes. Everybody says the same thing at senior management. No data strategy. Data doesn't connect to other data. There are pockets of information, but you have to trust that person over there with a spreadsheet. So I've seen this before. We had this back in the 90s at JP Morgan. We had it in the 2000s at Deutsche Bank. So the point is that most organizations, large, sophisticated, successful organizations, haven't thought about data strategy. Most of them are focused on technology strategy and where should they build a new system. The thing I demonstrated to management, and some of it's in here, it's a very simple calculation. I'm going to use NASA as an example because the same calculation that we used at JP Morgan in the 90s and is the same one we used inside SAIC in 2020. And it's the same one I used at NASA last year talking with leadership at NASA. NASA has about 4,500 or 5,000 systems across 10 mission directorates. They don't have an enterprise data bus or a distribution strategy. They connect point to point because that just seemed more efficient. So if you do the math, let's say it's 5,000. That's 5,000 connections between each of 5,000 systems. That's 5,000 squared. So that's a lot of connections. That's, what is that, 250,000 point-to-point connections. If we use a strategy, a data strategy like developing an operational data store with reference data services and certain key sets of master data management where we share IDs for the same kinds of data and map different representations of that ID into the main ID, a master ID, then we can cut it down to 5,000 connections. So you tell me, 250,000 connections or 5,000? I think I'd rather go, I'm sorry, 25 million, not 250,000. So 25 million point-to-point connections is hard. 5,000 connections to a mastering system or a bus or something like that is much easier. It's not easy, but it's much easier. So I got everybody to understand that case, and NASA agreed with this too. So we launched about a year ago a program at NASA called the Enterprise Data Platform, and my team is helping develop that now. So when you see the Artemis Space Launch System go up again next year, you'll know that all those monitoring systems and all those guidance systems are feeding data into a single data hub in a data mesh environment where there are different data products that are managed separately, but they're all integrated through a data fabric framework. And we can talk about that. That's a key data strategy that's coming up in the new world of graph databases and Databricks and Elastic MapReduce and things like that. So the first thing we said is we needed to figure out the strategy. We couldn't do it all at once. We couldn't boil the ocean. So this is a map of our conceptual organizational chart with our CEO who just retired. We have a new CEO as of a month ago. And you can see in the blue, those are all of our customer-facing business units. And in the green, those are all the support units that help. And I'm sitting over there way on the right in that furthest right ITO group. And I run a program in there called data. And I'm up here, there are two things in ITO, data and technology. And I run the data half. And I build a lot of custom apps, and I also help customers. So I also play on the dark blue side on the left. So we needed to make sure we handled the whole company properly, but we decided the right way to do it was to do the internal, the green stuff first, and handle the blue stuff later. So the vision was set up the building blocks for effective management. We had structured data, we have unstructured data. We needed to begin to think about our data assets. What are the data assets we have? Information about our customers, that's a pretty good data asset. Reports that everybody agrees work, that's a pretty good data asset. Feeds between systems that help us do our business every day, those are data assets. So we decided we needed to organize it because there was no organization. We needed to control this process. So we had to establish data governance. So we needed to know what data we have. We needed to classify and catalog all the data we have and make sure we know where it is and get rid of it when we can, if we're able to. The first question our chief risk officer asked me when I joined is, I need to find my data. Where is my data? She's not a technical person. She needed to be able to find data on demand. So we decided we had to organize data into domains and subject areas and sort of a model. We decided we needed to master certain critical data around customers, vendors, employees, and contracts, like any other business, just like JP Morgan or Tata Auto Services or British Aerospace. And then we also needed to adopt the Hippocratic Oath that first we couldn't do any harm, we couldn't break things. We needed to define requirements so we could deliver services at an enterprise level. So I was sitting in a meeting with a bunch of consultants and senior people, and they were kind of talking, and it wasn't very interesting. So I started to draw this picture, and I outlined a 3-year roadmap. And I hate to say it, we actually hit the mark. We're at 3 years now, and we've developed the knowledge portal, and I'll tell you about that later. It's much more than a knowledge portal. The vision was, when I joined, we had lots of siloed fiefdoms. We had people in the group who wanted to do their own thing. They wanted to share their data. They thought they owned the data, and they had lots of problems with the data because they couldn't connect it to the other people's data. Finance and HR data didn't have connectors. Procurement's really big in our business because we have to buy things for the government and then ship them to the government or build them out, connect them to other things and deliver to the government. So things like the Mark 48 torpedo we build for the US Navy. The Mark 48 torpedo has about 10,000 parts and lots of software. We have to buy all 10,000 of those parts, and we have to bill the government for them. We have to assemble them, test them, and deliver that torpedo, and we're delivering a lot of those torpedoes right now, given what's happening around the world. So the first step was to organize things, just catalog things and organize things into groupings. That's what we did by the time we got all the governance set up, got everybody bought in, we were able to sort of propose an organizational framework. And then the third thing we did in the third year, and we've just gone into production, is launch what then we called the next generation data architecture, which was a platform underneath all of our systems. And at SEIC, we have hundreds of systems. We don't have as many as NASA, but we've got probably 200 or 300 production large-scale systems and lots of smaller systems. So we needed a platform that they could talk to and share information. So this really kicked things off. Everybody looked at this. It took us about 3 months to walk it around and present it to groups and get people to buy in. Excuse me. But by the time we finished at the end of 2020, they decided to give us a budget. and let me start building a team. At the time, there were 3 people in the chief data office. Today, we've got about 75 people in the chief data office. Half of us are engineers, and I was an engineer, and I still sort of work in the tech. I need to be able to communicate with customers technically. I also need to be able to communicate with customers about business issues. So we've grown quite a team, and but we needed to get the buy-in by management before we could do this. They needed to know why I wanted to go spend billions of US dollars. So we needed to set the priorities. The first priorities were establish governance, comply with any mandates from the government, from other customers, from other groups we work with, and we operate around the world, but we're primarily a US government vendor. We needed to, what we decided to do in the first year, in the first 6 months after I was pushing the strategy out, my boss and I got together and we said, we need to get some currency. We need to get people to give us more money next year and the year after that. So we need to start giving them stuff now. They can't wait 3 years for that enterprise knowledge portal to come up. They need to start to get tangible, usable data now so that we can begin to quiet the crowd. So we decided to put half of our team into building classic Power BI and Cognos reports, some Tableau. We decided to get rid of Tableau for now, 3 years later, and build it on a traditional relational data warehouse using SQL Server so we could get started right away. So within a month of publishing this in September of 2020, we hired a team from inside the company. We didn't hire new people. We brought them in from our different organizations to help us do 2 things: to define requirements and define models for financial reporting, and to take those models and build them into Power BI reports. It worked. We've got everybody looking at the Power BI reports while we're building out this platform. And we've delivered about 250 or so drillable, visualized, and tabular reports that every part of the business now uses. When I joined, we had none of these. Everyone had spreadsheets. Everybody showed me their spreadsheets, and they said, how can we automate this? And we said, give us your spreadsheet. And we went out and pulled all the data from the core data systems, from HR systems and finance systems and business development CRM systems. We pulled it all into our new data warehouse, modeled it, and delivered reports. So now, today, the company has all of the operational reporting that it needs across all of its sectors and functions. So that's been a big win. And it gave us the currency to get a few $1 million to build what was our next generation data architecture, but now we call it our cloud native data platform. We're operating in Azure Azure Government, and Amazon AWS Government at a pretty high security level because of the business we're in. And we have to operate between IL4 and IL6, which are levels defined by the NIST 181, NIST 800, 181, I'm sorry, and 182, which are 2 standards that describe the kinds of protections you need around government data. Because government data includes all sorts of things, and you've seen about the hacks. A few years ago, the Office of Personnel Management got hacked, and millions of US government employees' data was exfiltrated to a bunch of hackers overseas outside of the US. That's a bad thing. No one wants to lose their data to a hacker, because then you're going to get chased down with identity theft issues and things like that. So anyway, let me step through the strategic priorities. Implement governance. Can I tell you, please, if you get involved with data strategy in a large organization or a small one, please begin with governance. Define your strategy, your charter, your mission statement, and begin to define policies and standards. But don't push too hard on policies and standards. just begin to understand what they are, because they exist, but they're implicit, and they may need to be normalized or organized a little bit. But the thing that worked for us with governance is we defined and developed an agile process. We call it Agile Data Ops now. And what we do is we bring in requirements in an agile process through an intake. And anyone who wants to get data, has to come through this process. And it can be quick. It can take a day. It can take a month. It can take longer if they're not organized. We had one today. We handled 4 new requirements for our AI product group in 30 minutes. Once you had the intake, then you prioritize, and then you manage. But so we had to put this governance office together to manage that process. And today it runs without any oversight. It runs really well. Well, no, that's not true. It has oversight without any new features or functionality being introduced. It's running well. Then we decided the legacy platform that had begun to be built a few years before I got there but never worked, we needed to finish it and get those reports that I mentioned out to people. So we pulled a team together and built that ODS data warehouse and integrated it and built all the analytics and reports, and also built quite a few data products to feed other systems from a centralized source so we could begin to eliminate those point-to-point connections. Then we decided, not only does finance need finance data and HR need HR data, but HR needs finance data and finance needs HR data. So to handle that, we needed to understand what the requirements were, what the restrictions were, because again, in government, there are a lot of restrictions on sharing of data. So we built an access control framework. It's very similar to some of the zero trust principles you might have heard about. So delivering integrated data, though, in structured reporting and analytics has completely changed the way this company operates. Now people get reports every morning that it took them months to build, and they were always 2 months behind schedule. We're in the middle of rolling out our master data solution, which is based on the information I mentioned in my dissertation a few minutes ago. We're using that party identifier to connect all the dots about our customers, because it turns out customer data lives in hundreds of systems in our company. In the past, and currently, we still haven't fixed this yet, we can organize it in the warehouse and use some dimensions to cross-reference data, but we don't really have a master key where we can in real time point to data that exists in HR, finance, operations, artificial intelligence, and in real time pull them all together into a single data product and look at something. And I've got some great examples about that I can talk to you about later if you like. So master data, knowledge management, and finally, we needed to make sure we complied along the way. We can't make shortcuts. We can't decide that we don't need to do things that we think the government won't notice. We needed to do all the things in cyber, in legal, in risk management, and in our various policy management shops that we needed to comply with. So I'm going to step through these things pretty quickly. The Atlantic Charter was a pretty famous charter. If you don't know what it is, go look it up. We needed to design a structure for the governance program, and we set it up this way. We have business sponsors, and we needed to get the sponsors on board. That was the whole point of getting the reports out there. And once they started to get reporting and realized that we could change the way the company operates, they started writing us checks to do more work. We needed a steering committee that meets periodically. We met yesterday. We had an hour scheduled. I think we met for 33 minutes. We don't waste anyone's time. We have a very straightforward format. It's not a discussion forum. It's not a catered lunch. It's a meeting to go through an agenda and to make decisions. In the governance board, we look at the items in intake that we are taking in or have taken in. We look to prioritize those intake items, and the governance team has 12 voting members and about 60 members that join and listen. And then we monitor each of those items as they go through the life cycle, and then we track them when we deliver them to users. So we had a lot of big announcements recently about some good delivery. And then we have working groups, and the working groups cover the gamut of activities that we do as a company. Everything from HR data to artificial intelligence. So this is kind of the policy framework. We were a little ambitious here, but those green things in the bottoms are how we manifest the policies and the standards. I'm going to skip through some of this stuff and get to a few more things at the end, except we decided to come up with this concept of shared services because no one was sharing nicely. We put together a strategy for focusing on core corporate data, not customer data, not data about customer programs, but data about our internal systems and contracts and revenue and expense, the things any company would want to keep track of. We kind of defined the tools we'd use to manage governance, to make sure we're all talking the same language. And we decided to start with a catalog and a glossary with a dictionary. We wound up choosing Elation right there in the middle. We also use SQL Server. It turns out we also use ER Studio, the green circle on the top. We have a little Informatica. We're trying to simplify though, so we're trying to get some of these things out of the house, and so we have one of everything and not more than one of anything. So yeah, so we decided that the key thing to keep people happy was to build out a portal. That's a screenshot of our corporate intranet portal, and you can see we decided to suggest that we put a bug on the portal for reporting and analytics. It's now called My Data. And My Data, we're getting about 6,000 unique users a month, and they're running about 250,000 reports a month off My Data. So it's probably one of the most used websites in the internet. We picked our catalog. We had a bake-off, as you might imagine. We passed over a catalog that we really liked, which was a hypergraph strategy called data.world. Highly recommend you guys look at it. I can introduce you to them if you want to talk with them. I know the founder and the people who run the business pretty well because we partnered with them on a number of programs. We put together a process. It's now much more elaborate than this, but a process for change management because there was no process. We put together, this was our legacy approach to master data. What the previous CIO had done is he went out and he bought Microsoft MDM server, and he said, okay, we have master data. But if you guys know what master data is, it's not a server. It might be several servers, but the servers has to be filled with the right software. And the Microsoft master data server is really a cube, an analytics cube that takes legacy information from systems of record and organizes it. But what we showed it didn't do, and I'll give you one example, is we went to some of our vendors and asked them about their ideas to tell us. We used the party example that we talked about at the beginning of the class. Using my identifier framework, we went out and went to several sources and built corporate trees for our company, SAIC, and 6 other competitors. We did it using open data from the government, including EDGAR, which is the SEC's database of company filings, financial reporting filings, and a few other systems. And we built the tree for SAIC and realized that it was 15 or 20 companies. So we asked all the vendors who were providing us data to give us their list of companies that were SAIC. We did this for 6 other companies, including one called Leidos, which is a company we spun off from 10 years ago. And Leidos has about 25 or 30 companies. We have about 15 or 20. The vendors told us that SAIC had 77 companies 80 companies, 110 companies. They were all over the map. They didn't know. We asked about the other companies, same problem. They were just way off. They did not understand how many people, how many organizations were in each company, but we figured out how to do it using the technique we talked about. And we realized the master data cube, so we said, let's look internally. And we looked internally at all the company systems, and we saw that our internal company systems thought of Leidos, the company that we spun off from, of 25 or 30 companies as a corporate entity. We saw that we thought Leidos was about 75 or 80 companies, not the 26 or 28 we proved it was. And we did the same thing for all of our other major customers and vendors and found the same problem. So we realized we needed a master data framework based on party information. We needed to be able to put the master data in front of the systems of record instead of behind it or in it, or behind the systems of record. So many people implement master data post-process, and that doesn't help you fix the next problem you're going to have. We put master data in front of the process, which is what I learned how to do at JP Morgan a long time ago, and all of a sudden you save a lot of money, a lot fewer errors, a lot fewer data quality problems, a lot faster time to knowledge. So I'll stop with this slide. This is based on an idea that Professor Talbert has, and a few of us have helped him develop it. He had a student that graduated my year who did a dissertation on positive data control. But we decided to outline how this new infrastructure would work. And the key is you don't have lines going vertically and going horizontally between the orange and the green and the blue boxes. Everything goes into that layer, which is all cataloged. We know exactly what every piece of data is that's flowing through that layer. And it goes back and forth between the systems and the people through this layer. So we know who's using it, what it is, how often it got used today. And this was our initial roadmap. I think by the time we rolled this system out, it had taken us almost 3 years. And so what we have today, and let me see if I have a picture of it here, is a cloud native data platform that we're migrating. We had a meeting right before this meeting with my IT counterparts and the OCIO, we agreed that we would build this out and begin our pivot in January. And so we're planning all the ConOps, all the RACI information. And in January, we're going to pivot over to this new system. Let me see if I can find it. It's a pretty cool thing. Again, it's a cloud native data platform. And I'm almost there. Let's see if I can get there. We have so many files. And this is really cool stuff, by the way. This is really state of the art. I think I'm going to have it for you. I'm trying to get a good version of this. I'm going to pull it into Visio. I think. And while I'm doing this, do any of you have any questions right now?
Great. Let me just, I'm going to double check to see if folks have any questions. Oh, Adiba was curious more on what we meant by technical debt in the previous slide. In one of your previous slides. Technical
debt. That's a discussion, Dr. Pierce, I've had many a time here and other places. I don't know why I can't see this. This is the CNDP. And a very simplified view of it. But let me go back to that technical debt. Where did I have technical debt? I know it's here somewhere. Here, let me look on the master slide. Well, I'll tell you what technical debt is. Technical debt are systems we built in the past that are hard to maintain and don't meet requirements we have today. So we have to do something to make them usable. I'll give you an example. When I was at Freddie Mac 15 years ago, we had a system called Midas. Midas was written in the 1980s. It was an old system, but it was very well written. The problem was, in a mortgage market, which is the business Freddie was in the 80s, they only had 30-year fixed coupon mortgages. Like, you couldn't buy a variable rate, adjustable rate mortgage. So it thought every mortgage was a 30-year fixed rate mortgage. The problem with that is that with all the innovation, we started to get more and more adjustable rate mortgages for various reasons. I've had mortgages, I don't know if you have, but they make your house more affordable. And an adjustable rate, an ARM, can make it much more affordable by going with short-term maturities and giving the bank the chance to raise their interest rate in 3 years, 5 years, 7 years, or 10 years when the adjustable rate period comes up. So we had to trick Midas into thinking everything was a 30-year fixed rate mortgage, because it's where all the banks in the United States would send their mortgage purchases per day. We tried to replace it, and it failed. I was not there for the whole period, but I was there right in the middle of when we tried to replace it. And part of the problem was it happened during the credit crisis. But another part of the problem is that it happened when our global credit crisis was happening, and it happened when we had a lot of competing priorities for that money. So Midas is still there. It's got wrappers around it. It's integrated with other systems. You send it a 3-year ARM. They'll trick it into thinking it's a 30-year fixed rate, and it comes out the other side, and we'll adjust it again to make it look like a 3-year ARM. So technical debt is our systems that don't do everything we need them to do, but they do something well enough that it's too expensive to explain it. And there's an old saying that I learned in finance: debt is cheaper than equity.
Oh, thank you.
Any other questions? Yeah.
Yeah. So I'll ask a question, because so many of our students, this is their first semester in maybe most of the students are in our information quality, but we have a few maybe in the information science program. So this is their first semester. So they're going to have another year or two before they graduate. But any thoughts or advice you have for them, in terms of getting their career started as data leaders?
Absolutely. First of all, this is a great degree. I was at the Data Foundation yesterday with a lot of people, very senior people, and a number of people were asking me about UALR. So you have a good degree. It depends where you are in your career. I came to the program to prove something to myself and to Dr. Rich Wang. Unfortunately, I met Dr. Pierce and Dr. Talbert and a few others, got to know some great people. And it really crystallized what Dr. Wang used to tell me, which is, you don't need a PhD, you already know it all. Well, I didn't know it all, but I knew a lot, and it helped me understand what I knew and what I didn't know. But I would say, look actively for internships while you're in school, and side jobs doing data work, not cooking hamburgers, but doing work with consultants. Because a lot of companies come to Dr. Pierce and Dr. Talbert and others and say, hey, we need some help. If you get a chance to work on a grant with one of the programs to get some real world experience with what, like Dr. Agarwal, what people need done, that's really valuable. And if you can get a job, I'm not sure, I know a lot of you are remote. I did most of my degree remotely, but I did some in Little Rock. It's worth coming to Little Rock because there are some local employers that will hire you. And getting into those programs, I know Dr. Pierce's organization has sent a lot of students to Walmart and to other local employers. There's some great employers in Little Rock, and it's a nice place to live. The Stevens Inc., the investment bank I mentioned, is right down in Little Rock. And I think companies around the world are finally, I've been doing data, Dr. Pierce and I have been doing data for a long time. And for a long time, we were relegated to the basement. And in the last decade, companies and governments have come to realize that it really is all about the data. And so, but you have to expose yourself to them. They don't know you're there. They may do a career fair at ULR, but if you don't show up, they're not going to know you're there. I was at a career fair at ULR about a year ago. Just about a year ago. And a young man walked up to me and handed me his resume. And I didn't expect to hire him. I just said, thank you very much. And he now works for us. He's coming up here to Washington, D.C. next month for an offsite meeting of our team. And I've now got, as I mentioned earlier, 4 ULR grads, 5 including myself, and 1 ULR student on my team. So you have to get yourself out there. The other thing I'd say is I learned by going from finance, and finance is a big world. I know people who do one thing for their whole career in finance, and maybe at different companies, but I have a friend who's a fixed income trader, a foreign exchange trader, and he's worked at all sorts of companies, lived all over the world, but he's only done one thing. With data, you can cross boundaries much more easily. So I went from retail banking, really building systems to manage automatic teller machines and the transaction processing in teller machines, to investment banking, to investment management, which are 3 very different businesses in the financial world. And they really describe most of the financial world in those 3 sectors. And then I went into government contracting with defense contracting, really. And I, as I mentioned earlier, it's the data language is the same. And actually, some of the things you're learning and you will learn are cutting edge technologies and about how to use cutting edge techniques that many engineers who are really smart don't understand. So I'd say it's important to get yourself out there. And you're not going to, I'm talking with my daughter who's graduating from college next year. I'm trying to help her decide what to do. And I'm trying to help her understand there isn't a perfect job. There was a saying when I got on Wall Street that I took to heart for 28 years, which is you either go up or you go out. So wherever you go, work harder than they ask you to, do more than they ask you to, be polite about it, be pleasant, communicate clearly. I can tell you the criteria I've looked for, I was trained to look for in banking, and I look for now, it's our mantra. The first thing we look for is attitude. What's your attitude? If you have a bad attitude, I'm not sure I want you on the team. If you complain a lot, if you have a bad reputation. So make sure your professional reputation is good and you demonstrate a good collaborative attitude. So the first is attitude. The next is aptitude. Are you smart? Can you do the work? We had a saying in banking, we didn't hire people for a skill set. We hired them for their aptitude because we could teach a smart person to do something. So learn while you're in the program, learn all the techniques, but use an open mind and think about all the different ways you could apply it. So attitude and aptitude are first, and then collaboration is probably the third most important thing today in today's world. And I can't tell you how many people I've seen not be successful who try to take all the credit and be the first person to, raise their hand. And it's good to be, aggressive and pleasant, but collaborate. Give your teammates credit, even if you feel like you deserve it, and work and be a leader. And that's the final thing, is leadership. We look for leaders in my organization, in my company. I've been fortunate to be in some very good situations, but it's not all easy, as many of you know. I've been in companies that have gone bankrupt. I've been, with my company, I had a couple of lean years where I didn't make a lot of money, and I had to use my savings to survive. So those are the key things: attitude, aptitude, collaboration, and leadership. And I would say if you keep those 4 principles in mind, smile, put your hand out when you meet someone at a career fair, give them a copy of your resume, and say, my name is whatever, Justin Magruder. I'm a student at UALR in the graduate program. I'd be very interested in understanding what kind of roles you have in your company. Career fairs are great. Online career fairs happen these days too. Job boards are great. At our company, SAIC, you'll see we have about 6,000 open jobs in the United States and around the world. Most of them are for U.S. citizens because of the work we do. Not all are. But you can find jobs that run from the associate level analyst to the senior PhD mechanical engineer with 25 years of experience building guidance systems. So there are lots of jobs out there. You got to go find them.
Oh, thanks.
How's that, Dr. Pierce?
No, that's great. Because we also have a large number of international students, and I think the positive thing is to know that, as Dr. Magruder is saying, we're seeing growth around around the world. And I know it can be kind of discouraging for international students because the way the immigration is written, when you come here as a student, they want you to be a student. And so it's harder to get some of the employment experiences. But there are opportunities to do research, to work with professional organizations, to get out there, to network. And really with technology now, you can kind of see if you're able, as they say, to find ways to get legally employed, with companies. And that is just, as Dr. Magruder says, you just have to be kind of persistent and keep checking job boards and companies to find out who is hiring, because you're bringing a tremendous asset. Because in addition to your technical skills, you've shown that you can travel, you can go to a new country, that you can handle multiple languages, that you can handle multiple cultures. And that's a very powerful selling set. And there are, as I say, for Dr. Agarwal and his lab, part of the reason he needs internationals is that he is looking at social media on a worldwide basis. And he can't be looking at it from a strictly Arkansas lens. He's got to have diversity, and he's got to have really a multicultural skill set. So just to give just a little bit of boost, be open, and look for opportunities, and look at multinationals or look for companies that work in multiple countries, because they'll generally or probably will have more of a career path in bringing on people from many different areas. Harder to maybe do it if you're looking at a company that's just based in Arkansas.
And I'd add to that, Dr. Pierce, that when I was in banking at JP Morgan in 1997, I set up JP Morgan's first offshore development team that was based in Barbados and in Mumbai. And what we did is we brought engineers and data architects from Mumbai to Barbados so they could be in our time zone. And they would, we started building software there. Now that business has just exploded. And as you know, Cognizant, and there are all sorts of companies over there that are global. My neighbor was the chief information security officer at Cognizant until a few months ago. They had a management change. But she traveled the world, and her team traveled the world. She did cyber and physical security, actually. So I would encourage you to look at whatever country you're in, the big companies that have a multinational presence. If you're trying to get into kind of that corporate world, that's another thing. The boutique consultancies are interesting, but it's much better, in my opinion, to get experience in an industry and learn a business, whatever that business is, and then set up your boutique or go with a boutique than to start in a boutique. Because with a boutique, you don't get the exposure you get at JP Morgan or Tata or Cognizant or British Aerospace.
Great. Well, Dr. Magruder, thank you so much for joining us this afternoon. This was terrific. We're kind of at the end of our session here. But again, thank you so much. We really appreciate you sharing the insights and your experiences when it comes to being a chief data officer and all the different components and pieces that you need to get to all work together.
Yeah. Absolutely. Dr. Pierce, I'd be happy to come back if I'm welcome. I really enjoy talking. This is good.
All righty. Well, take care and have a great evening.
Take care. Have a nice day, everybody.